This is Electromagnetism lesson 9, and this is the transformer power equation. So we're hopefully going to be able to recall it, but it's normally on data sheets. Anyway, we're going to also apply the power equation to solve some practice problems, and then we'll do some exam style questions. First of all, let's start with a recap question. So if you want to pause and have a go at this one. So a transformer has 200 turns on its primary coil. It has an input voltage of 70 volts. And an output voltage of 350. So is it a step up or step down? Well, it's stepping up the voltage, so it's a step up transformer. And then how many turns are on the secondary coil? Alright, so it's voltage primary divided by voltage secondary equals number of turns on the primary divided by number of turns on the secondary. And what you need to do is to rearrange this to make number of turns on the secondary the subject of the formula. So let's flip both sides. So voltage secondary divided by voltage primary is equal to number of turns on the secondary divided by number of turns on the primary. Then same as always, we just need to get rid of the divide MP, so we're going to times by MP on the other side. So it's voltage secondary times number of turns on the primary divided by voltage primary equals number of turns on the secondary. So the secondary voltage is 350 times 200 turns on the primary coil divided by primary voltage is 70 volts. So that gives us 1000 turns. Alright, let's move on. So transformers can be very efficient. So if you assume a transformer has an efficiency of 100%, which obviously in real life it doesn't, but at GCSE we always make that assumption, then the power output into the primary coil is equal to the power output from the secondary coil. So the power on the primary is equal to the power on the secondary. And as I've stated, in reality, no transformer is 100% efficient. Power will be lost in the coils and in the core, mainly due to heating effects and small fluctuation currents called eddy currents. But if you do A-level physics, you'll learn about that then. So transformers not only change voltage, they change current, which if you've done the national grid, you should already know. So for example, if voltage increases, current will decrease. So the opposite happens. So if voltage goes up, current goes down. If voltage goes down, current goes up. So the power in is equal to the power out. So that's power on the primary equals power on the secondary. There's an equation from electricity, P equals IV or P equals VI, voltage times current. So that gives us this equation. So the left-hand side is the power on the primary coil, the right-hand side is the power on the secondary coil, and we use VI as our equation. That's normally given on data sheets, so you don't really need to remember it, but you know, if you can remember these equations, it just speeds up the process when you're doing your exam. So make sure you've got that down, and then let's do some practice questions. Alright, let's start with this one. You can have a go at this if you want straight away, just pause. Let me take you through the answers. So a transformer has a primary voltage of 1000 volts and a primary current of 0.5 amps. If the secondary circuit has a current of 0.01 amps, we need to calculate the secondary voltage. So really straightforward. So current primary times voltage primary is equal to current on the secondary multiplied by voltage on the secondary. I just need to put the numbers in really. So current primary is 0.5, voltage primary is 1000, 0.5 times 1000 is 500, equals the current on the secondary is 0.01 times voltage secondary. So to get voltage secondary on its own, make it the subject, we just need to get rid of the times 0.01. So we're going to divide by 0.01 on the other side. And that gives us a secondary voltage of 50,000 volts, or you could say 50 kilovolts. Let's move on to the next one. If you want to pause and have a go at this one. So calculate the potential difference across the primary coil, so that's just voltage. Of a transformer when the current through the primary coil is 2 amps, potential difference across the secondary coil is 230 volts, and the current through the secondary coil is 14 amps, so relatively straightforward. Current on the primary times voltage on the primary is equal to current on the secondary times voltage on the secondary. And we need to find VP, voltage primary. So the current on the secondary is 2 amps. Oh, no, it's not. It's 14 amps. So it's 14 times voltage secondary 230. And that's equal to current on the primary, which is 2, times the unknown VP. So voltage primary is equal to, we just need to do 14 times 230. Get rid of the times 2 by dividing by 2. So 14 times 230 divided by 2. So that gives us a primary voltage of 1610 volts. Alright, let's move on. Right, let's have a look at this question. So diagram shows the basic structure of a transformer. Explain how a transformer works. So you've done this one if you've been following the lessons plenty of times now. I know I keep doing it and you might be wondering why. It comes up quite often and it's not a very well done question, so I like to get students just to keep repeating it. Right, so I'll give you the answers to this one, the mark scheme. So once again, alternating current in the primary coil. Normally I say alternating voltage, alternating current in the primary coil. Then you need to talk about your alternating magnetic field inside the iron core. And then you just at the end need to talk about your alternating voltage and your alternating current in the secondary coil. 4 marks. As you can see, it's a 5-mark question. So you want to get 5 points. I'm not sure why actually. Oh no, never mind. Right, let's do another question. So we're going to move on to this calculation. If you want to have a go at that one, and then I'll take you through the answer. So a transformer is used to change the 230 volt mains electricity supply to 12 volts needed to operate a low voltage halogen lamp. The current through the halogen lamp is 4 amps. So what we need to do is calculate the current drawn. So that's the primary current. Right, let's have a look. So current primary times voltage primary is equal to current on the secondary times voltage on the secondary. So current drawn by the transformer from the main supply, we're looking for IP. So current primary, do this one a slightly different way. It's times by VP. So the opposite of timesing by VP is simply dividing by VP on the other side. So it's current secondary, voltage secondary divided by voltage primary. So the current on the secondary is halogen lamp, that's 4 amps multiplied by the voltage on the secondary, which is 12 volts, divided by voltage primary, which is 230. So if you calculate that, 0.208, so 0.2 amps. Hopefully that went okay, let's move on. So if you're going to pause and have a go at this one. So the diagram represents a simple transformer used to light a 12 volt lamp. When the power supply is switched on, the lamp is very dim. Give one way to increase the voltage of the lamp without changing the power supply. So that's relatively straightforward. You can increase the number of turns on the secondary coil, which is more than likely the answer that you gave, or you could decrease the number of turns on the primary coil. The next bit says, what is meant by the iron core being laminated? Now, this has been taken off, I know, the AQA spec for GCSE physics, but it was on for a long time, and I'm not sure about other exam boards specifically, but it's really easy. Laminate, you've probably heard of laminate flooring. The iron cores, they're just laminated, so they're made of like strips of iron rather than a full solid block. So they're constructed in thin layers. All right, let's do some more. So electrical energy is distributed around the country by a network of high voltage cables. For the system to work, the power is generated and distributed using alternating current rather than direct current. Why? Transformers only work with AC, so in a power station, the voltage is approximately 25,000 volts. We then need a big step-up transformer to put the voltage up between 144,000 to 400,000 volts. When we have high voltage, remember, for the power to remain the same, if voltage increases, the current will go down. that's the main reason for putting the voltage up really high. Less current means less thermal energy losses. So transformers are an essential part of the distribution system. Explain why. Used to increase voltage, reduce current, which reduces the power loss along the cables. All right, let's move on. Right, if you want to try all this. Right, so the first part, the transmission cables are suspended high above the ground. Why? So there's several meters of air, and air is actually a really good electrical insulator, which is obviously, a really good safety aspect. You don't want them at ground level. And it reduces the chance of earthing or sparks, for example, and it also avoids people touching them. Right, let's do the calculation next. So let's have a look at this one. Power station generates 100 megawatts of power. This is actually not useful for this question at all. At a voltage of 25 kilovolts, which links the power station to the transmission cables. It has 44,000 turns and it's 275,000 volt secondary coil. So I'll write down the equation. So voltage primary divided by voltage secondary equals number of turns on the primary divided by number of turns on the secondary. Calculate the number of turns in the primary coil. Well, we don't have to flip it for once. We just need to get rid of the divide ns. So we're going to times by ns on the other side. So voltage primary times number of turns on secondary divided by voltage secondary gives us the number of turns on the primary coil. So voltage primary is 25,000. Multiplied by number of turns on the secondary. 44,000 divided by voltage secondary, which is 275,000, which gives us 4,000 turns. Right, just one more question left. It's quite a challenging one, so if you want to pause and have a go at this one. So a laptop is connected to a UK mains power supply. Transformer in the power cable has a primary coil with 575 turns, secondary coil has 50 turns, and the current supply to the laptop, which is the secondary, is 3.45 amps. Calculate the PD, potential difference, which is voltage, the charger supplies to the laptop. So we're looking for secondary voltage. So, oops, get rid of that. So voltage primary divided by voltage secondary equals number of turns on the primary divided by number of turns on the secondary. And we want voltage secondary, so flip both sides. So voltage secondary divided by voltage primary equals number of turns on the secondary divided by number of turns on the primary. So we're going to times through by VP. So voltage secondary is equal to number of turns on the secondary divided by times by the primary voltage divided by number of turns on the primary coil. So the number of turns on the secondary coil is 50 multiplied by voltage primary. Now it's UK mains power supply, so that's 230 volts. If you got that, really well done. Number of turns on the primary, 575. So that gives us a secondary voltage of 20 volts. Now we can calculate the currents in the primary coil. So voltage primary, current primary times voltage primary equals current on the secondary times voltage on the secondary. So current primary, to get that on its own, to make it the subject, we need to divide by VP on the right hand side because they're multiplied. So current secondary, voltage secondary divided by voltage primary. So the current on the secondary coil is 3.45 amps times voltage secondary, which we calculate to be 20 volts, divided by voltage on the primary, UK mains 230. So that gives us a current on the primary coil of 0.3 amps. If you got that, really well done. That's a tricky one, definitely level 9. And that's it. So thanks for watching. I'll speak to you soon.